Hi, welcome back to the Chemistry Unit in Science 1206. I'm Miss Ledwell, and in this video, we'll be doing a review of some chemistry terms. So let's begin. Our first term is the atomic number. In our previous discussions, we explored the nature of elements, their organization in the periodic table, and the importance of chemical symbols. Next, we will discuss how the information in the periodic table forms the foundation for Bohr-Rutherford diagrams, starting with atomic numbers. Remember that the atomic number in the periodic table tells us how many protons are found in the nucleus of an atom. So for hydrogen, the atomic number is 1. This tells us that there is 1 proton in the nucleus of a hydrogen atom. For a neutral atom, the number of protons is always equal to the number of electrons. So for a neutral atom of hydrogen, there is 1 proton in the nucleus and 1 electron surrounding the nucleus. Another point to note is that the atomic number is always a whole number. Now let's review the atomic mass. Atomic mass refers to the average mass of the atoms of an element. It is a measure of the total mass of all the particles in the atom, including protons, neutrons, and electrons. The atomic mass is generally measured in atomic mass units, abbreviated AMU, and it is a decimal number. For the element gold, we can see the atomic mass is the decimal number underneath the word gold. For sodium, the atomic mass is 22.989,76928, right underneath the word sodium. The atomic mass is mainly determined by the number of protons and neutrons in the atom's nucleus, because electrons have a negligible mass compared to the other subatomic particles. The mass number represents the total number of protons and neutrons in an atom of an element. The mass number can be approximated by rounding the atomic mass to the nearest whole number. Let's look at a couple examples: phosphorus and zirconium. So for phosphorus, the atomic mass is 30.973761998. To get the mass number, we would round that to the nearest whole number. The mass number of phosphorus then would be 31. So that represents the total number of protons and neutrons in an atom of phosphorus. For zirconium, the atomic mass is 91.224. To get the mass number, we're going to round that to the nearest whole number. That becomes 91. So in an atom of zirconium, there are 91 total protons and neutrons. We've already talked about how to determine the number of protons and electrons in a neutral atom. Let's look at how to determine the number of neutrons. The number of neutrons in an atom can be calculated using the mass number and the atomic number. The formula is the number of neutrons is equal to the mass number minus the atomic number. Remember, the atomic number is the whole number up in the corner. So, for example, for phosphorus, we had the mass number was 30.97 rounded, which was 31. So we would say 31 subtract the atomic number, which is the whole number in the top, 15. 31 minus 15 gives us 16. Phosphorus has 16 neutrons. One way we can represent the arrangement of electrons in an atom is with a Bohr-Rutherford or energy level diagram. The Bohr-Rutherford diagram shows how many electrons are in each energy level or electron shell around the nucleus. The first shell around the nucleus holds up to 2 electrons. The second shell holds up to 8 electrons. And the third shell holds up to 8 electrons. The fourth shell holds up to 18 electrons. The electrons in the outermost shell strongly influence the properties of an atom. These electrons have a special name. They are called valence electrons. The shell that contains the outermost electrons is called the valence shell. Let's look at some examples. Our first example is sodium. Sodium has 1 valence electron, and the outermost shell is the valence shell. Silicon is our next example. How many valence electrons does silicon have? If you said 4, you are right, and that last shell is called the valence shell. Now it's time to continue on to the next video. Before you continue, take a moment to briefly pause. Stand up, stretch your muscles, glance away from your screen, and prepare to learn more about the world of chemistry. See you soon.